So this is Chapter P, Section P.6, which is complex numbers. So we're going to talk about complex numbers, operations with complex numbers, complex conjugates and division, and then talking about how this applies to quadratic equations. So we learned last year a complex number has an imaginary part and a real part. So this is the standard form of a complex number. So the A is the real part and the BI is the imaginary part. So addition and subtraction. So basically if you have A plus BI and C plus DI, you're going to combine the real parts and you're going to combine the imaginary parts. So for example, if we had 3 plus 2i plus negative 5 minus 7i. So we're going to combine the 3 and the negative 5, and we get negative 2. And then we combine the 2i and the negative 7i, and we get minus 5i. So that is how we add. Same is true if we're subtracting. So you're combining the real parts, combining the imaginary parts. Okay, multiplying complex numbers. So this is very similar to if you are multiplying binomials, but there's a couple of extra steps that you have to pay attention to, especially when you're multiplying I times I. So we are going to use FOIL with this. So first would be 3 times 4, which is 12. Outer would be 3 times negative I, which is minus 3i. Inner would be 2i times 4, which is 8i. And then last would be 2i times negative I, which is minus 2i squared. Okay, so now we're going to combine the i's. So this would be 12 plus 5i minus 2i squared. So what we have to remember is that I is equal to the square root of negative 1. So I squared is equal to the square root of negative 1 squared, which we know that the square and square root will cancel each other out. So that means that I squared is just equal to negative 1. So if we go back to our expression we have here, we have 12 plus 5i minus 2, and then we can substitute in, instead of I squared, we can write negative 1. So that's going to turn this into a positive 2, so this would actually be 14 plus 5i. And that's our final answer. Okay, so the next thing is complex conjugates. So these are going to be helpful when we're dividing. So it's important to understand how to find a complex conjugate of any complex number. So if I have 2 plus 3i, the complex conjugate would be 2 minus 3i. If I have negative 5, let's use not plus. Let's say negative 5 minus 8i. My complex conjugate would be negative 5 plus 8i. So you'll notice the only thing that's changing is the imaginary part. So the real part is staying the same, the imaginary part is the opposite of what it started out to be. So even if you didn't have like a real part, if you just had negative I, the complex conjugate would be positive I. Okay? So now we're going to use that to divide complex numbers. So we're going to write the complex number in standard form. So the way that we divide, and we did this last year, is we want to multiply by the complex conjugate of the denominator. So if we start with A here, the denominator is 5 minus I, which means the complex conjugate is 5 plus I. And remember, whatever we do to the denominator, we have to do to the numerator. So I'm going to multiply. So the top becomes 15 plus 3i. And then if we FOIL this out, so there is a shortcut. And the shortcut, I will tell you, is just saying a squared plus b squared. And so your a would be 5, and your b would be the number in front of I, which is just 1. So we know that this is going to be 5 squared, which is 25, and 1 squared, which is 1. So this is going to turn into 26. But I want to show you, just so that you understand that, if we FOIL this out, it works the same way. So if I FOIL 5 times 5 is 25. Then the outer is going to be plus 5i, minus 5i, and then minus I squared. Okay, so if we simplify this part right here, we can cancel the 5i and negative 5i, and we remember that I squared is negative 1. So if I have a minus a negative 1, we know that's going to be plus 1. So this would turn into 26. So that means, and that's what we talked about right here with the a squared plus b squared. So that means my final answer in standard form would be 15 over 26 plus 3 over 26, oops, I'm running out of space, I. So there's my final answer. Okay, now we're going to do the same thing for b. So the denominator is 3 minus 2i, so I'm going to multiply by 3 plus 2i. Okay, so this one is a little bit extra steps because we have to FOIL on the top. So the top is going to turn into 6 plus 4i plus 3i plus 2i squared over. Now again, we could FOIL out the denominator, or we can use that little cheat right there of a squared plus b squared. So our a is 3 and our b is 2. So that would be 9 plus 4. So if we simplify all this, we know that this I squared right here is negative 1. So we have a 6 and we have a negative b4 plus 7i over 13. So again, it always wants us to write it in standard form, so that just means we break that apart. So we write 4/13 plus 7/13 I. So there's my answer. Okay, so the last thing we're going to talk about is how this relates to quadratic functions. And basically, you can have quadratics that have no solution. So if we think about it, we can have a quadratic that crosses the x-axis 2 times. So that's 2 real solutions. That would be this one right here. We can have a quadratic that just sits on the x-axis. So that would be the second one. So 1 real solution. And then we could have a parabola that doesn't cross the x-axis, which would mean that we have complex solutions or no real solutions. So you can use the discriminant, the part underneath the square root on the quadratic formula, which is the b squared minus 4ac. And you can use that compared to 0 to tell us how many solutions we're going to have. So if we look at this, we're solving a quadratic solving a quadratic equation, and we want to know, so we can use that kind of quick answer to tell us if we're going to have real solutions or no real solutions. So remember, we have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So our a is 3, our b is 4, and our c is 5. So if we just look at the b squared minus 4ac, that is going to be 4 squared minus 4 times 3 times 5. So this would be 16 minus, this would be 20 times 3, so it would be minus 60. So we know that this 16 minus 60 is going to be less than 0. So that means that we're going to have no real solutions. So let's go ahead and solve this out and see what we get. So this is going to be negative 4 plus or minus. We already know from our discriminant over here. So we take our calculator and we do 16 minus 60. We're going to get negative 44 over 2 times 3, so we're going to have 6 down here. So that means we have negative 4 plus or minus. So another way of writing this right here, so we have square root of negative 44. So we can write that as the square root of 44i over 6. And then if we want to simplify, so sometimes your problems are going to ask you to simplify. So remember, if we have the square root of 44, that is 4 and 11. And 4 is 2 times 2. So if we simplify the square root of 44, we get 2 square root of 11. So this is negative 4 plus or minus 2 square root of 11i over 6. So now we can divide everything by 2. So we could say x equals negative 2 plus or minus square root of 11 over 3i. And that would be our exact answer. So it depends on if it wants an approximate answer or an exact answer, but that's leaving it as an exact. So let me know if you have any questions.